Okay, first video for the course Economic Growth and Sustainable Development. And first of all, welcome to my garage, which has been turned into my recording studio. So this is like the intro lecture. I'm not quite sure what to say because we're going to have an intro on Zoom on Tuesday. This is now Sunday where I'm talking into the camera here a couple of days in advance. But I think I'll just talk you through some of the background, even though I might do this again on Tuesday. So we'll start with the home page, okay, the web page, econintern.se Rob Susdev 20. Okay, I hope you've all found that from the Slunic page. So, what does it say there? In the course, you'll build up your understanding of the process of economic growth and its links to environmental quality and resource use. And you'll learn about policies for sustainability and the management of climate change in an international context. Furthermore, you'll learn about the research process and scientific writing. Great preparation for your master's thesis. And of course, there's all sorts of links and loads of information on that web page, including old videos of lectures from previous years, which will become, redundant kind of when I've recorded this year's stuff. But there's also videos of me going through the exercises in previous years, and I'm not going to redo those, okay, so those are what you've got there for the exercises. So, given Corona, the course will be organised around a large number of short videos. I'll try to keep them to 15 minutes, some of them might go up to 20, max 25, which I'll record during October and November. It's now 1st of November, never mind. We'll have a small number of meetings which will be student driven, comments, questions, discussions. Okay, so those meetings will not be me burbling on. It's kind of up to you to determine what happens in those meetings. And the first one, we'll talk through it all on the 3rd of November, and that's going to be super important, okay, to decide exactly how we're going to manage this. Okay. The course is based around my book. Okay, the book, I still haven't got around to trying to publish it, or I haven't put it into a publishable form, but I'm certainly intending to publish something along these lines. The Economics of Spaceship Earth. So the course is called Economic Growth and Sustainable Development. The book's called Economics of Spaceship Earth. What's the course about? It's like macroeconomics, big picture, long run development of the human economy on Earth and the interactions between the human economy, natural world, etc. And of course, the human economy, of course, as you know, is totally dependent and a sort of part of, in one way, the natural world. Notice that there's 2 lots of readings as well, or 2 kind of takes on the readings. There's one document or one place where I give you guidance on articles and other useful sources, and there's a more formal reading list as well. If you want to sort of show someone else, this is what we did in this course, you can print out that reading list. Okay. So, I was about to say, without further ado, let's get into the introduction to the course, but I think perhaps I should also just say a few words about myself, and then actually I might round off this video in the interest of having very short videos. So I'm Rob Hart. I'm professor, or I have the chair, if you like, in environmental natural resource economics at SLU. And basically this course is like, it's my course, it's about the stuff I do research on. I'm a macroeconomist, environmental economist. I'm interested in the very long run, big picture, sustainability. Okay, I publish in reasonably regularly. I'd like to publish even more often, but in the top field journals in environmental economics, like so-called GEAM and GERI. Those are the top two field journals in environmental economics. I also publish in good journals, good general journals, like Journal of Economic Dynamics and Control, European Economic Review, etc. So I know what I'm talking about. Okay. Which is not to say that you should just take my word for everything, because a big part of my teaching philosophy is, and this especially kind of sticks out at more at first year level, but I'm not trying to tell you like this is how things work. I'm trying to give you the tools, the analytical tools to analyze for yourselves. Like, this is one way of looking at how things work. I like this. I think we can learn this from it. But then you can play with the same tools. And decide for yourselves to an extent what do I think? What do you think we can learn from these tools? Okay, so I want you to understand and be able to use the tools, but then the conclusions you draw, that's much more of a matter of opinion. Okay, so this is what we do in economics, right? We develop these models, which are models of reality, and hopefully they're teaching us something about reality. And it's a kind of a very clear question. Do you understand the model? Can you work through from the assumptions and derive the conclusions? That's all very clear cut, but then like, okay, what can we learn from the model about reality? That's much more open for discussion, and we're going to have a lot of those discussions in the course, and hopefully that's one of the things we'll be doing on Zoom or in the meetings when we're actually talking to each other. Okay, I was talking about stopping this video, but I think I'm going to plow on actually. I'm going to go over to the first set of lecture notes, part 0, Introduction to the Course. Okay. So we're going to start by talking a bit about the book, slide 4 out of 20, Economic Growth on Spaceship Earth. And then I've got this quote from George Orwell: "The world is a raft sailing through space, with potentially plenty of provisions for everybody. The idea that we must all cooperate and see to it that everyone does his fair share of work and gets his fair share of the provisions seems so blatantly obvious that one would say that no one could possibly fail to accept it, unless he had some corrupt motive for clinging to the present system." Or maybe, if he was an economist. I don't know. So, for Orwell, when he thinks of Spaceship Earth, he's thinking about distributional questions, fairness. We're all stuck on this spaceship together, we need to agree, share things out, etc. And you can have a whole course with that quote as a starting point, and it would be super interesting. But that's not what we're going to do in this course. Okay. Not because it's not interesting, just because we can't do everything. So what are we going to do? We're going to follow more from Kenneth Boulding. The closed economy of the future might be called the spaceman economy, in which the Earth has become a single spaceship without unlimited reservoirs of anything, either for extraction or for pollution, and in which, therefore, man must find his place in a cyclical ecological system which is capable of continuous reproduction of material form, even though it cannot escape having inputs of energy. Okay, this is more the starting point for this course. Okay, so we're not so much looking at fairness, distribution, etc. We're looking at sustainability from the more, can we carry on doing stuff this way? Physical limits, ecological limits. that side of things. Okay. So given that, page 7, what sort of questions can we ask about long-run management of the economy? So I've thrown out a few examples. What's desirable? What's feasible? What's optimal? Okay. So what's desirable might be more vague. Oh, you know, we want this, that and the other. We want everyone to be happy. We want so on and so forth. What's feasible is like, okay, what can we actually achieve? What's optimal? We set up some function and say, you know, the optimum is when we maximize utility. So A might be the kind of question asked by a philosopher, right? B might be the sort of more engineering question. An engineer might ask that question. C is the classic economist's question. Yeah, you set up this function and then you want to optimize. What does the function look like? Frequently, it's a utilitarian style function. We're trying to maximize, for instance, the sum over all households of UH, where UH is the utility of a given, of each household, indexed by age. And then what is UH? That could be the sum over time of little UH beta to the t, where beta is a discount factor. We often have discounting in economics, right? Almost always. So beta will be less than 1. This is telling us that utility earned further into the future, yeah, and typically, utility, this little UH is a function of C of t, where C is consumption. So we get utility from consumption, but utility today is worth more than utility in the future because of this discounting. This is the kind of thing. This is a utilitarian approach, and it's the most common approach in economics. We could also follow like Rawls, which is another philosophical approach. So the philosophers set up utilitarianism, what's desirable, oh, we want to maximize everyone's utility, and then the economists put numbers on it. Yeah. Rawls, who was another philosopher, so this guy, this is like what, Bentham and so on, isn't it? But Rawls said we want to maximize the min of U1, U2. So if this is each individual's utility, min of that is the smallest element. We want to maximize the smallest element. So Rawls said we should try to organize society to maximize the utility of the person with the least utility. Okay, slide 8. So if we're going to get a bit more concrete, questions about the management of the economy, given that we're doing economics. What would happen given laissez-faire? If we just had no regulation, what happens? What happens if we keep going like we're doing at the moment? Maybe, depending on the question, it might already be laissez-faire, in which case this is the same question, but if we've got some regulations in place, what happens if we just keep them in place? Or what happens if we introduce some specific new regulations, some new taxes or whatever? What would happen then? A more general question: how would a social planner organize resources in the economy? If you had an all-powerful social planner who could just tell everybody what to do and was benevolent, wanted the best possible outcome, what would the social planner tell people to do? Would she tell people to go and pump oil, or dig coal, or pipe up gas, or build windmills, or what? And what should the regulator do? So those of you who've done the policy course, I guess a bunch of you would have done the policy course with Sean, I guess. I hope. Last summer, or last spring. You should it should be very familiar to you guys, yeah, I think. How could a regulator get us close to the social planner's allocation? So the social planner doesn't need to worry about markets. The social planner can just work out the best allocation and then tell people what to do. The regulator has to find instruments in the market to try to get people to do like the social planner would tell them to do. So the slides are a bit funny order here. But we're going to focus a lot. The classic thing to do is like focus on D and E, if you like. We set up a model, we derive the social planner's solution, then we try to find a regulator's solution that gets us close to the planner's solution. This is like classic. A lot of my research papers are kind of using this classic methodology. And you also compare to laissez-faire. But in this course, actually, we're going to spend a lot of time focusing on these. So it's slightly less ambitious. We're trying to just understand what on earth, so to speak, is going on. Why do we see the historical tendencies that we see with regard to pollution, resource use, etc.? And given that understanding, what predictions can we make for the future? And if we just assume if we just say, let's test different instruments, what will happen? Okay, so it's a simpler approach than this more rigorous approach of actually saying, what will the social planner do? What will the regulator do? What can the regulator do? Okay, but it's quite hard enough as it is, and we will of course talk to a degree about these aspects as well. Okay, I'm just going to pause this and gather my thoughts for a sec. Okay, I decided what to do. I'm jumping to slide 13 out of 20. So what are the main themes in the course? We're often just trying to understand what's going on and understand the effect of specific instruments and avoiding the more complex questions of what would be optimal to do. But what are the main themes? What are we trying to understand? Three main themes, as you can see on page 13. One, technological progress and economic growth. Technological progress is absolutely fundamental to the human takeover of spaceship Earth. Okay, so it's like, yeah, it has to be the starting point to get a grip on technological progress. If you want to understand what's been going on over the last few centuries or even the last 70,000 years in terms of humans taking over spaceship Earth, you have to understand technological progress. Then we're going to focus on production under resource constraints and whether, for instance, resources like oil, coal, metals, whatever, running out is going to put the brakes on the global economy. And that's, yeah, it's maybe a little bit of sort of yesterday's question in a way. But that was a huge, huge question that blew up in the 70s with the oil crisis in 74 and various other things kicking off there. The short answer is we can't expect resource constraints to put the brakes on global economic growth anytime soon. Okay. And then the third question is pollution, or the third theme in the course is pollution and sustainability. Okay. Which is of course a more modern question. There's far more focus now on economic activity causing pollution rather than economic activity causing the exhaustion of resources. And we're going to ask why we keep emitting so much pollution, why we seem to emit more and more, why in certain cases we see steep declines in pollution, and can we expect to see that in more and more cases, and can we expect ultimately a clean, bright, sustainable future? The answer is, of course, we don't know, but we're going to see reasons to be hopeful, optimistic, and reasons to be pessimistic as we go through the course. Okay, I'm going to jump back now to slide 10. Macroeconomic methodology. So what do we do when we build models? Let me just check, is there anything more? No, there's not. Okay, so what have we got on this slide? Consider the following aggregate production function. Y equals ALL to the 1 minus alpha ARR to the alpha. So what is this? This will be labor, and this will be some natural resource, and this would be labor productivity, and this would be natural resource productivity. And this basically is a Cobb-Douglas production function. We're saying, and by the way, this labor we can interpret as labor and capital together. It's like each worker with associated capital. And this goes up when the workers get more skilled and the capital they've got gets more sophisticated. This goes up when the workers and capital and the technologies also get more resource effective, so we can get more output from the same quantity of resources. And without going through all the derivations, based on this production function, we can pretty quickly work out that PRR over PLL, where PR is the price of resources and PL is the price of labor, should always be alpha over 1 minus alpha. So we spend the same amount on resources compared to what we spend on labor and capital over time. It doesn't change. Okay, that's a prediction of this. And so we spend, say, 5% of global product goes to resources, 95% to labor and capital, say. When we look at the data, we find that this is broadly true. Okay. Does that mean that we should accept this production function as true because it fits this prediction? Because the data fits this prediction? No. Okay. If we did accept this production function as true, that would also imply that raising resource productivity, AR, is a waste of time. Because you can just take this AR outside. Raising AR will just raise overall productivity and it won't help save resources. Typically you'd think we raise resource productivity, we need fewer resources. But here, given this formulation, we raise resource productivity, it's the same as raising overall productivity. We'll end up using more resources probably. Definitely not less. The point is that just making a model that fits one set of observations is not enough to say, therefore this model is true, therefore we can draw all these policy conclusions. Okay, don't bother subsidizing research into clean technologies, because it's not going to help reducing resource use. We cannot draw that conclusion just because this prediction fits the data. Okay. Why is that? Well, there's so many different ways of explaining it, but basically, for a given trend in the data, there's potentially an infinite number of different models that could explain that trend, right? So just because you fitted one trend in the data does not mean you've got a good model. Okay, and we're going to spend a lot of time in this course trying to say, okay, is this model really, okay, it fitted this bit of data, but is it really telling us anything meaningful? It's a hugely, hugely important thing that I want to teach you to grapple with in this course. Okay. I'm going to pause here again and gather my thoughts. Okay, so this is going to be super quick because this video has already been way too long. But I'm going on to slide 14 about the course. 16, your own development. 4 skills. Learn to think. That is primary. Okay. You also need to learn to present your ideas both orally and in writing or on a computer. You need to learn to handle and program a computer to simulate models. We're going to work mostly, the thinking is primary, a bit on the presentation, quite a bit on the writing actually. Thinking primary, quite a lot of work on writing, a bit on presentation, nothing on programming, unfortunately. That's up to other courses to deal with. Examination. Check out the homepage. Check out the grading criteria. There's Gobbets, a research paper, and the written exam. You need to pass all elements to pass the course. Having passed the elements, the number of bonus points in addition to that determines your grade. Okay, but check out the details. But basically you need to tick off passes on everything, and then if you do better than just pass, you'll be picking up bonus points. So I've done a preliminary schedule, the link is in the notes, and of course I'm sure you've all seen it. When I made the schedule, I was really hoping we could do a bunch of stuff IRL, face-to-face, but that's looking pretty tricky now. We'll talk about it on Tuesday. My current plan is that basically the lectures and exercises will be by pre-recorded video. We'll have regular discussions via Zoom, or possibly a hybrid of IRL and Zoom. The research paper seminar, that is an open question whether we could gather to do that. It would be really nice if we could get together for that. The written exam, I really hope we can do IRL. That's not till January. Okay, that's the end of this overlong first video. See you again shortly.